One of the first things to do when setting up an experiment builder project is to specify some hardware properties of the project. Hardware properties can be found and edited either from the Devices tab of the Structure panel or by going to Edit, Preferences, and then editing the hardware settings under the Devices section of the Preferences. First, you can specify the type of eye tracker you are using and the particulars of its usage. These settings can be made in the EyeLink section of Devices. Setting the properties related to the EyeLink hardware will make it so that the Experiment Builder project will send commands to the host PC to configure the EyeLink hardware based on the options you choose. If you're using the EyeLink 1 or 2, you can just choose your eye tracker type from the tracker version drop-down window. If you're using the EyeLink 1000, then you can additionally specify your mount type, which can be tower, desktop, arm, or long range. And if you're using the desktop mount, then you can additionally specify whether the illuminator on your mount is to the right or to the left of the camera via the desktop version property. Then, for the desktop, arm, and long-range mounts, you need to specify the mount usage. Head-stabilized chin rest mode versus head-free remote mode, and monocular versus binocular tracking. The EyeLink 1000 Plus settings are similar to those of the EyeLink 1000, but there's no need to specify which side the illuminator is on for the desktop mount, and you additionally have the binocular option for remote head-free mode. For the EyeLink Portable Duo, the only property to configure is mount usage. You can choose the head-stabilized chin rest mode or the head-free remote mode. Alternatively, for any of the eye trackers, if you prefer to configure the experiment on the host PC side of things, you can select Current for these properties. Using Current will make it so that Experiment Builder will not send any commands to change that particular eye tracker property, and the host PC will use whatever settings have currently been selected in its interface. Next, and importantly, when you run an Experiment Builder project, it will temporarily change your monitor's resolution and refresh rate based on the display settings of your project. The positioning of stimuli in Experiment Builder is based on pixel coordinates, so you'll want to make sure that you're setting your display values correctly. It's a good idea to use the native resolution of monitors, as that will most likely maximize the monitor's timing performance. Also, for things like gaze contingent studies, you'll want to make sure that you set your refresh rate to be as high as your monitor supports. In this case, there aren't any gaze contingent aspects that would require a quick update to the monitor, so using 60 Hz and the native resolution of the monitor that is being used here is fine. You'll also want to make sure to build your project so that you are maintaining similar luminance levels from calibration to drift checking or drift correcting to the presentation of experimental stimuli. Otherwise, the pupil could change by an excessive amount, which could disrupt the accuracy of the calibration model. This experiment presents its stimuli on a gray background, so it's configured so that the backgrounds for any camera setup actions, drift check actions, and display screen actions match that gray that is being used. This way, the pupil won't change size drastically from calibration to stimulus presentation. If you choose the background color of display screen, camera setup, and drift correct nodes in preferences before adding these nodes in the graph editor, then they'll already be configured with the desired background when you later do add these nodes to build your project. Finally, if you're using audio in your experiment or any other devices, you'll want to check and edit their properties as well. If you want to save your project settings as defaults, then you can do that through the Preferences dialog as well.